Bismillahirrahmanirrahim. Today we are going to discuss the topic damping, which is defined as any effect that tends to reduce the amplitude of vibration of an oscillatory object with time is called damping. Now, if we explain this topic, we will say that until now we have discussed oscillatory motion that were for ideal systems. If they were considered with simple pendulum or mass attached to spring system, but they were considered to be ideal system. An ideal system is that one in which neither energy nor the amplitude of the vibration decreases with time but remain constant. That is for ideal system. Now here we will discuss the real system. In real system, the amplitude as well as the energy of the oscillating object decreases with time. That doesn't remain constant. For example, if we consider the motion of a simple pendulum, let's consider that this pendulum here, it is the equilibrium position, and we displace it from this equilibrium position to an extreme position A and release it. Then it will start moving towards equilibrium position O and will start continue motion due to inertia and reaches to point A dash, while it will continue its oscillatory motion in between these 2 points. For the ideal system, we consider that this amplitude is constant as well as its energy is constant. But in practical life, this doesn't happen because there are resistive forces that this simple pendulum faces. These resistive forces includes the air friction, air resistance, and that is gravity, which reduces the amplitude of the vibration with time, and hence its displacement also reduces and its energy decreases, while the oscillator comes to rest at equilibrium position O. And this type of oscillation is called damped oscillation. The main reason for damping is the resistive forces. Now this is the graph between displacement and time for the oscillatory motion of the simple pendulum. Here the displacement in the first vibration is maximum, that is considered to be x naught, while for the second vibration its oscillation or its amplitude decreases to x naught 2, while in the third vibration its amplitude or displacement becomes to be x naught 3. Now here we can see that the x1 is greater than x2, similarly x2 is greater than x3, and so on. x4 will be considered to be at 0 position, at equilibrium position. The amplitude will become 0, and this happens due to the resistive forces due to which the oscillator loses energy, and that loss produces decrease in the amplitude as well as in the displacement, and the oscillator comes to rest finally at equilibrium position O. Now this damping system is used in our automobile vehicles and suspension system for reducing their frequency of vibration when it moves on a bumpy road, which makes our journey comfortable, more comfortable. And thanks. It's